Good morning, Grade 12s. This is Mr. Nambani, the subject advisor for physical science in the Mutao district. I hope everything is well with your camps that you are holding at your schools and trying to finish off the syllabus with your teachers. But the idea for this video now is to try and clear out the misconceptions and the common errors that you are doing. So basically we'll be looking at the layout of the exam for paper 1 as well as paper 2. But in this video we'll start with paper 1 as part 1 of everything that we intend on doing. So let me not waste time, because I believe each and every one of us, we are committed somehow, somewhere. So firstly, let's start by looking at how the exam is going to look like. So the very first thing for paper 1, I usually say let's look into the distribution of marks. The idea for the distribution of marks is when I sit down and prepare for my exam, there has to be a guide that says to me where can I get or achieve my maximum marks. So when you look at the table here, it says if I can focus more on mechanics as well as electricity and magnetism, somehow I will be able to look into the 65 marks there and also the 55 marks there. So it says those are the most two important topics that I need to focus on. But me focusing on each one of them, it says I need also to say something and be able to say something about waves, sound and light. I should be able to perform certain calculations, give correct definition also for matter and materials. Yes, they do not contribute that much to the 150, but it's always important to be able to say something there as well. But the main idea today is let's outline the misconceptions that we are facing here when we work with mechanics, as well as the misconceptions that now we are faced with in electricity and magnetism. So the idea is in each topic we are going to try and look for the achievables. The achievables will assist us in such a way that it's non-negotiables. It's things that each and every one of us should be able to get a maximum marks thereof. So I will start with mechanics, and the first part will be Newton's laws. So when we check on Newton's laws, it says here we need to be able to define laws or give definitions and laws, draw a free body diagram for objects that are in equilibrium or accelerating, and thereof apply Newton's laws of motion for a variety of equilibrium and non-equilibrium problems. So this is why we say it will be plus minus 16 in an exam, but now our achievable mark should be somehow around 7. So it means somehow with no matter what type of question I am faced with, somehow the possible amount of marks that I can get here should be now 7. So in the PowerPoint that I compiled, I said the important definitions that we need to look for is normal force, frictional force, static friction, kinetic friction, and also be able now to state Newton's first law, Newton's second law, as well as Newton's third law. So if this can be addressed, it means each one of them will be 2 marks in an exam. So it will be my 2, and then I should also be able now to draw the correct free body diagram. Then from the free body diagram, it will be the application of Newton's laws or applications of mostly Newton's second law. So the reason for this is that when we look at our free body diagram, it should be correct because it is the one that informs now the calculations that we are going to work on. So I brought an example here of what was written in September 2021. So I'm going to try and show you the achievables that we spoke about. So automatically you can easily see, if you know your definitions correctly, you will be able now to get these 2 marks. So the 2 marks thereof should be now you being able to give the correct definition of what is a normal force. Thereafter, we say, if once my definition is correct, because my definitions are non-negotiables, each and every one of us should be able to get maximum marks in terms of the definitions. So me defining a normal force, I will be able to say the force or the component of a force which a surface exerts on an object which is in contact and which is perpendicular to the surface. So I am looking now for the key words there. So I cannot necessarily omit any key words in the definition. So hence we say study and learn your definitions as they are from the formula, from the exam guidelines and terms and definitions that were shared with you during the year. So the force of a component which the surface exerts on an object which is in contact and it's perpendicular to the surface. And you can easily see here that it is now 2, 2 or 0. So that is the 2 marks of my achievables. Thereof, draw the correct free body diagram. So if I'm going to draw the correct free body diagram at 2.2, remember, I must have now my surface, and then I'm going to have a dot to indicate the object. So it must start now with what? It must start with a dot for me to be able to say I am drawing a free body diagram. Then I have the force applied. I have now the frictional force, because we were told that it is going down. And then I have my FW. And then I have my F normal. So this will be correct, because now the indication is if a question or a free body diagram it's 4 marks, then I must be able to get 4 vectors. But look at what I did. I have an arrowhead for each and every one of them. I also have a label for each and every one of them. So if your force, your vectors do not touch the object, you lose marks. If you don't have a label, you also lose marks. And if you don't have the correct label or name of the force also, you lose marks. So we need to ensure that whatever we do, we kindly now ensure that we have the correct names for the forces, they touch the object, and at the very same time, they now represent the length or the magnitude of each and every vector. So now this is the 6 marks already, the 2 from the definition, the 4 from the correct drawing of the free body diagram. So it goes back to my achievable of at least having 7 marks from Newton's laws. So everything thereof that follows will be somehow calculations. Hence we are able to say now we need also to apply calculations in terms of calculating for the acceleration, tension, coefficient of friction, as well as now the normal force. So let's look at this question that we are busy with. A block of mass 100 kg is sliding down a rough inclined surface at a constant speed. Now there comes a keyword, constant speed. So it's another misconception or common error that we do to say if now we have a constant speed, it says to me my F net should be equals to 0. That is very, very important. Not F net, but let's say the acceleration thereof should be equals to 0 meters per second. So that is the key. because this information, it will assist me in terms of getting the correct answer for the information that is given. But now, however, from the free body diagram, if I am going to apply Newton's laws or Newton's second law, it's somehow going to be complex, because now the free body diagram that I have, it does not include all the forces in terms of it moving down. I was informed that the object is sliding down on a rough surface. So it means there has to be a force now that is somehow pulling it down. So what will be the ideal way of doing it? The ideal way of doing it is, if you have an inclined plane, kindly resolve your weight into its components. So I am going to have my force applied, my frictional force, as well as my normal, and then I will have my F perpendicular, and then I will have my FG parallel. So in this case, remember, these two here, they just represent FW. So it will be easy for me to say, when I work with the calculations, I will focus now on the forces that are causing an object to move. So it's easy now to say, from this, I am omitting an error of forgetting that FG parallel is part of the calculation. So from the free body diagram, that is correct. It's easy for me now to link it up with the calculation thereof. So it's quite easy to say, I will start now with my F net is equals to MA, because remember, it's a calculation, but now I need to substitute into the calculation. Then I will choose to say, let's choose downwards as positive. So every force that is moving downwards will be positive. So I will have F net, which is just the sum of FG parallel plus FA plus FK, which is equals to MA. And now remember, after doing this, it's then that I can substitute the values, is then that I can write in such a way that I include now the choice of direction. So me doing that, I will say now FG parallel is given as mg sine of theta, which will be positive, minus now FA or F minus F, and then as well as minus the friction, which will be mu k mg cos of theta, and then the mass there will be 100 multiplied by 0. The 0, remember, is from that constant speed. Thereof, it will be just a matter of substitution. But I wanted to show to you that from me choosing the correct formula and as well as adding other information that comes thereof, it's easy for me to get a mark there. So that mark that I am getting, remember, it will be now 2 plus 4, which is 6, plus 1 from the formula, which will assist me now in terms of getting my achievable in this particular question or this topic, which is now around 7 marks. So if I can do that throughout the question paper, it says at some stage I will be at a percent of about 50% in each of the topics. So the overall performance for the paper will also be at 50%, which is decent, because we need now to develop strategies of how to pass. So that is basically it with the calculation. I will not go into detail, because the idea here is just to share a strategy, is just to share how best can I be able to achieve the maximum marks. So once you are able to say, I am able to give the correct definitions and laws, I am able to draw the correct free body diagram, somehow I can apply Newton's laws of motion, then definitely I will be able to get something around 7 to 6 marks. So moving forward now, the misconceptions and common errors that we picked up were that candidates omit keywords in definitions. I explained that further to say, when you give your definitions, kindly use your terms and definitions, use your exam guideline, because the exam guideline thereof addresses all these definitions that you need to know. So if you do not learn your definitions as per the exam guideline, automatically you will be omitting keywords, and once you omit the keywords, it says to us you do not know how to write down the correct definition, and you will be losing marks for that. Hence it says here, stick to and learn the definition in the exam guidelines. So we don't use the definitions from the textbook, we don't use the definitions we got from certain materials, but we only use definitions that come from now the exam guideline. Then many candidates labeled their free body diagrams incorrectly, also omitted arrows and labels in the free body diagrams, and drew forces that were not in contact with the body. That is what I explained to say it is always important to check whether your vectors are touching the body. Your vectors, they have now the correct labeling, and now they have the arrow. So if you do not have that, it means we cannot award marks for that. Some candidates failed to realize that Fnet is equals to 0 at a constant velocity due to the fact that acceleration is equals to 0. So hence I said, when we look at the question that was given to us, we were told that it was now moving at a constant velocity or a constant speed. So constant speed, we relate it to acceleration being equals to 0. Therefore, the acceleration, if it's equals to 0, automatically the Fnet will also be equals to 0. So it's a principle, it's the underlying concepts that we want you to understand, to say if it's moving at a constant becomes a problem thereof. So Newton's laws is a topic that I believe each and every one of us should be able to achieve maximum marks. But I outlined exactly how to go about at least getting a 7 out of the plus minus 16 marks. Now moving further on, it says a method of solving simultaneous equations can be used to solve for unknown in the equation, and this method should be taught thoroughly in class. This question was somehow easy because the focus was just one object. But in the near future, be ready now to have a situation where you have a two-body system, A and B. So you should also be able to solve situations where now we have two bodies that are involved. Remember, this one was just an easy one to do because we are dealing with one object. So when you prepare now moving forward, also include where we have a system of two bodies, because once we have a system of two bodies, the expectation is you must now perform a multi-step. So performing a multi-step, it's moving now into simultaneous as well. So when you move to simultaneous, it means you need to draw a free body diagram for A and then free body diagram also for B. So in so doing, it says we need to have free body diagrams, but now one will be asked. The examiner will not assess you to draw both of them. So if one is asked in an exam to say let's draw for B, then automatically you should be able to draw for A. So that is basically it with Newton's. If there's any other thing there, it will be just an issue of applying Newton's third law and maybe Newton's first law in terms of inertia, and then all in other things will be clear in that regard. So let's move on and look into a projectile motion. So for projectile motion, the important definitions there, we don't have much of loss. It's a projectile and free fall. So it says to me I should be able to give a definition of what is a projectile. I should be able to give a definition of what is a free fall. So this automatically I know it will be around 2 marks. And the idea here is if it's 2 marks, then, and I understand this, in the possible 15 marks that I am looking for, it means somehow I should also be able to get the 6. But the first thing to do is, does it apply to be a free fall? Remember, hence I say at number 2, conditions of a free fall. So for an object to be a projectile, or for an object to be in a free fall, it says to us the only force acting on it should be a force of gravity. So if that is not the case, for instance, when you are working with a rocket and so forth, then there's a acceleration from the engine, then it means it is not a free fall, because now we are moving into a situation where we have the force of the engine against the force of gravity. So if that is the case, it means we need now to look into the condition of a free fall. So for it to be a free fall, the only force acting on it should be the force of gravity. Hence, I will say it's easy for us now to say if it is going to be 15 marks in an exam, I should be able to explain what is meant by a projectile, what is meant also by a free fall. So because these are definitions, I am expecting to get at least 2 out of the 15. So somehow I need 4 marks in order for me to get this minimum that I am looking for. Then use equations of motion to determine the position, velocity, and displacement of a projectile at a given time. At a given time. So what must I do? Use equations of motion. But how best can I use equations of motion? It's quite easy. The first thing to do there at number 3, it says choose direction. Very, very, very important. Remember, we are working with 1 dimension, so we know that our projectile can only go up or down. Our projectile can only go up or down. So the best thing to do is choose your direction. I always prefer to say, let's choose upwards preferred direction. I always say, now let's choose upward as positive. Now, what does that mean? It means now everything that is going down, for instance, your G, which is equals to 9.8 meters per second, your G will now be negative in most cases. So this assists me in terms of now when I do my calculations, when I perform everything, I don't confuse myself in terms of the choice of direction. So I will always prefer, let's choose upwards as positive. Then by so doing, it helps a lot, and then everything that is going down will be negative. But now the key thing is, when you choose your direction, the problem is once you cannot associate the correct vectors with your direction, it's when you start now losing a lot of marks. And when you choose a direction, preferably draw now a trajectory for the given problem. What do we mean by drawing the trajectory? All I'm saying is, if you are given a statement that a ball from a certain height was thrown vertically up and then came down past the starting position and then somehow it hit the ground. So this will be the trajectory that I am going to draw of the motion of the projectile. This assists me to assign labels to it, to say this is my A, this is my B, this is my C, and this is my D. So even if I intend on breaking down the calculations or the information that is given, already I can be able to say, but I am given V initial here, but at this particular point, VF at maximum should be easy, should be equals to 0. So if I am working from A to B, it becomes easy because I have now all the information that I need. If I am working from B to C, it becomes also easy for me to be able to identify the information thereof. Thereafter, I am able now to work from C to D. So the trajectory allows me to have sections or parts of the problem that I am able to attend in terms of what is being assessed by the examiner. So drawing the trajectory is just says you are understanding clearly what the question wants you to answer. Even if they can introduce now the second ball thereof. Once you have the trajectory and it was told to us that a certain ball now was dropped also after a certain few minutes, it's easy to accommodate it because you'll be able to see where to you are working from. So it's easy if a trajectory has been drawn. Write down the data. Only need 3 variables to do the calculation. That is very true. We only need 3 variables to perform calculations. But the bullet that follows says 2 variables are given, 1 is hidden. So it means in a statement, 2 variables will be given and then 1 will be hidden. So the one that is hidden, it's where now we apply the signs. I will make an example with this one that I just drew a trajectory for. If I am calculating anything at AB, so let's look at A at AB, the motion of this projectile from AB. Automatically, V initial is given. I will say it was just 5 meters per second. 5 meters per second is given. What else is given that I know of? I definitely know G is always there, which is negative 9.8 meters per second, because the decision and the agreement is I choose my up as positive. So this is the 2 that I say somehow will always be given. But there is one that is hidden. Which one is that? It's this one at V final. The V final at B, if I don't know that at maximum height V final is equals to 0, because I am not going to be given that in an exam. So I will not be able to get my other variable. So once I know VF is equals to 0 meters per second, then it means I have the 3 that I need. So this 3 that I need, then I can be able to say which equation is applicable for me. The examiner can ask anything, but now if I have V final, I have V initial, I have A, then the question should be about time. If I am looking at this one, I have V final, I have V initial, I have G, which is the acceleration, then the question should be about the displacement or even the height thereof. I can even further go into this one to say if I have V initial, I have T, but in this case T is not given, so automatically it says this equation will not be applicable somehow for me to work with on on A. Or it will be applicable if I was given to say the time taken from A to B was maybe 2 seconds. But for now, that information is not given. So this is how best I can say you choose your equations from the formula sheet. If you are not using the formula sheet, then everything is going to be complex for you and difficult and challenging at the same time. So the idea is once you get to question 3 in this case, which is projectile motion or vertical projectile motion, it's always important to look at the equations of motion. So the idea is 2 variables will be given, one will be hidden. The one that is hidden, that is where now the science comes in. So once you are able to identify the 3, believe you me, everything will work out best. Because if you cannot identify the 3, automatically it says you will not be able to answer correctly. Then as for the graphs, we have a chance of being exposed to a graph of position versus time, a graph of velocity versus time, a graph of acceleration versus time. But now for the graph of acceleration versus time, we know that the only force acting on an object is the force of gravity. So acceleration will be the same throughout. So it will be something like 9,8 throughout. So we will not have any challenges relating to acceleration versus time. So when we look at position versus time, of which the question was asked was based on position versus time. So it's one of the graphs that the examiner can ask. But the application will still be the same. It's just an issue or a matter of me understanding exactly or drawing the correct trajectory thereof. So it says the position time graph below, not according to scale, represents the motion of a ball thrown vertically downwards with a speed of 3,28 meters per second from the edge of the roof of a high building of 35 meters. The ball hits the ground and in contact with the ground for 0,1, the ball bounces off to the maximum height at x above the ground. So like I said, if you are able to interpret and draw the trajectory for this, everything will become easy somehow. So I'm going to try and say, if this is the roof or the height of the building and that is my ground, and I know that this particular ball was thrown vertically down and then it hits the ground and then bounced to a certain height x. So can I say I have A, B, and C there at x? Of course I can. So it allows me now to understand fully what is it that I am working with. Can I assign values that are given? Yes, I know that this particular height is around 35 meters, or it is given as 35 meters. Do I know the initial velocity? Yes, I know the initial velocity, which is equals to 3,28 meters per second. So this is me now writing down, analyzing the data that is given from the stem. So if this is the case, automatically it says somehow I should be in the right way of getting my achievables. Remember, my achievables in this particular question should be at least around 6 marks. So it says explain the term projectile. So that will be free 2 marks. Thereafter, calculate the speed at T1. So where is T1? T1 is here at B. T1 is there at B. So I'm going to write down my data of the information that is given. So basically, I am looking for the motion from A to B. So At A, I have initial, which is equals to 3,28 meters per second. What else do I have? I have G, which is 9,8 meters per second squared. What else do I have? I have delta Y, which is given as 35 meters. Can I calculate VF? Yes, I can, because now the question thereof is the speed of the ball. So I am not going to complicate it. I am just going to say it's easy for me to understand fully that once I have the 3, then I go to my formula sheet, and when I get to my formula sheet, I'll make it in such a way that I am able now to choose an equation that relates to the information that is given. That is how easy it can get. So I have V initial, I have V final, I have delta Y. Yes, then I can calculate the V final thereof. So it shouldn't be complex even if the graph is given. So the trajectory thereof assists me in terms of arriving at the correct answers. So the choice of direction, remember, it's very, very important. But now that everything here it's somehow moving down, I can easily say I am choosing my downwards as positive. Remember, you work with what the examiner has given you. So in such a way, it will be easy for you to understand. So that will be the 3 marks that I can easily get. So I have the 2 and the 3. So it means I'm already at around 5 marks in this particular chapter. Thereafter, it says now, calculate the time taken for the ground to hit T1. So I'm also looking at now AB, you see. So the trajectory shows me or indicates to me at which position I'm at which part of the motion I am looking at. So once I know that they are asking for T1, I can now easily say, but I have also V initial, I have G, then I have just calculated my final velocity at 3.21, so it will be easy for me also to calculate for A, for T1. So the idea is work with a trajectory, draw the trajectory. The trajectory will somehow assist in terms of you not being far from what is expected. Remember, there's a lot of things happening in an exam. We panic and everything. But now, for us not to lose the focus, it means we need to have a strategy or a plan or a way of saying the best way for me to get to the correct answer is if I develop a strategy or a method of working with that. So this is what I say when I say let's look at how many marks are allocated to vertical projectile motion. So it will be plus minus 15 marks. So it means somehow I should be able to get my 6. So this is how I get my 6. So in this case, this one was 18, but already I have received or been able to get the maximum there. It will be 3, 6, and then 8. So somehow I'm in the right direction of getting my achievables. Moving further on, it says at number 4, position versus time, velocity versus time, acceleration versus time. So the examiner what did is the first graph that was given to us, this graph here, is position versus time. But now when we move further on to 3.3, it says draw a velocity time graph for the ball the moment it is thrown until it reaches the maximum height x. You see, so what does that say? It says now we are also expected to be able to draw the graphs as well. So as drawing the graph, it means it clearly says indicate the values of T1 and T2, the velocity of the ball at time at T1 and T2. So the expectation thereof is let's have now and be able also to draw the graph. So the calculations will be given, yes. From the graph we can easily calculate, but after calculation also we will be expected to draw a graph. So that is the hint in an exam to say if the graph is given, also expect to draw. If the graph is given, also expect now to calculate from the graph. If the graph is not given, then thereafter you will be expected to draw. So once you are able to do the two, retrieve data, do calculations from the graph that is given, from the statement or the calculations that we have done, if you are able to draw the graph, believe you me, you won't experience any challenges thereof. So that is basically it with vertical projectile motion. It's quite an easy one to get maximum marks on, but the idea is draw your trajectory. The trajectory will assist us in terms of ensuring that we get the minimum achievables that we are looking for. Moving further on, it will be momentum and impulse. So with momentum and impulse, we are looking at around 12, between 10 to 12 marks in an exam. So important definitions includes defining momentum, impulse, stating the principle of conservation of linear momentum, defining what is an isolated system, elastic and inelastic collision. It's 2 marks that are non-negotiables because it's your definitions and it's your laws. So there's nothing more you can do, but the only thing you can do is learn your definitions from the exam guideline given. The only one that I did not add here is the one that says define or state Newton's second law in terms of momentum. So it is a new one that, not necessarily a new one, but it is the most recently asked question lately because majority of us are unable to state Newton's second law in terms of momentum. So we will look in the question that was given to us in September exam or the prelim exam. It says here a car of mass 1085 kg traveling east at a speed of 33 meters per second collides head-on with a car of mass 3450 traveling west at a speed of 28 meters per second. Immediately after the collision, car A moves west at a speed of 5 meters per second. Ignore the effects of friction or ignore friction. So first things first, the achievables. What is it that I can easily get marks from? From the definitions and laws, use the impulse momentum theorem, that is F net multiplied by changing T is equals to M changing V. Apply now conservation of momentum to the collisions of two objects moving in one dimension along a straight line with the aid of appropriate sign convention. So what does it say here? It says also, because I am working with vector quantities, it's important for me to also choose direction. Very, very, very important. So I will choose now the direction to east as positive. So the intention is I'm trying to get a maximum of 5 marks or a maximum of 6 marks in this regard. So the easy 2 marks will be me getting the correct definition there. So I should be able to say stating Newton's second law according to, okay, in terms of momentum, I should be able to say the net resultant force acting on an object is equals to the rate of change in momentum. That will be now my 2 marks. So kindly go and revise this particular definition. I have a feeling that because it has been assessed quite a lot, there was a lot of challenges and common errors that majority of us were doing. We're omitting the words like rate, omitting words like change. So kindly ensure that you close that gap when you prepare now moving forward. So at 4.1, the resultant force acting on an object is equal to the rate of change of momentum. Then that will be my 2 marks. Then it says calculate the velocity of car B after the collision. So that is where the achievables comes in. Apply conservation of momentum to the collisions of 2 objects moving in 1 dimension along a straight line. So it is for collisions. So already for collisions, I know what must I do. I must now apply conservation of linear momentum. So me doing that is analyzing the situation at the best way possible. Also receiving some information from my STEM as well. So the STEM will tell me anything that has to do with car A, everything that has to do with car B, and as well what happened after the collision thereof. So from this, a lot of information can be extracted, and the diagram thereof also supports what has been given in the STEM. But remember, it is a collision, so what must we apply? We must apply conservation of linear momentum. So I want to show you something here. It will be now the sum of momentum before is equals to the sum of momentum after. Then you break it down to say, but what happened before? Car A was traveling independently. Car B was also traveling independently. So I am going to have M of car A and V of car A, plus now M of car B, M V of car B. And thereafter what happened? They also moved separately. Hence they say now immediately after the collision, car A moves west at a speed of 5 meters per second. So if the examiner gave us another information of saying they moved together, they were united, or they moved as a unit after the collision, it would have been a different scenario. So in this case, we are able to say, but it means M of A, V of A, plus M of B, V of B, they were now moving separately and independently thereafter. So it will be just an issue now of substituting the information that is given. So we said we take east as positive for car A, so car A is 1085, moving at 33, plus now 3450 multiplied by negative 28 meters per second. Why the negative? Remember, we chose now towards east as positive. So, but car B is moving to the left or towards west, so it is going to be negative there. Then we substitute, we have 1085, but we are told that now it is moving to west, so west is negative, so we'll have negative 5 plus now 3450 VB. That is what I am looking for. So already you can easily tell that majority of things have been done. I chose my formula, I did my substitution with the conversion of the correct sign, because that is what the achievable is saying. Apply conservation of momentum, collisions between two objects in one dimension along a straight line with the aid of appropriate sign conversion. So I did my sign conversion, hence I said it's a plus. So everything that moves towards east must have a plus. Everything moving to west must have a negative, so hence the negative were assigned to this particular 2. So in this, I can further do my maths and solve for VB, and then I will get my VB as something like 16,05 meters per second. But now there's a problem and there's a challenge with this. We have developed a strategy that says, let's work with what we call Fsort. So the Fsort will be now for the formula, substitution, answer, unit, and direction. So once I'm able to apply this every time when I'm working with calculations, everything will become easy. I will not make any mistake. This assists to say, when I look at the information that is given, or me applying the principle, I will have 1 for the correct formula or application of the principle. Thereafter, I will have 1 also for the substitution. I will also have 1 also for the substitution. So I have the answer with the SI unit, 100%. Am I working with a vector quantity? Yes, I am working with a vector quantity, so it means I must assign now what? A direction to that. So assigning a direction, I must also be able, because it was moving, the final answer was negative, so it will move west. So I must maybe have it here, VB was minus 16,05 meters per second. Then I concluded to say it was moving west. So if you check, there's a mark for the final answer. There's a mark also for the direction. So it says to me, for me not to lose any marks thereof, it's important if I follow what? If I follow this analogy of Fsort. I will have my formula, I will have my substitution, I will have my answer, I will have the SI unit associated with the answer, and then now add the direction thereof. So this principle here of Fsort assists me in terms of not losing marks for omitting the SI unit, for not giving the correct direction. So hence we say that when you check, the mark is given for the answer with the correct SI unit as well as the direction. So you are going to lose a lot of marks if you did not apply the Fsort. So Fsort is there for us to say this is a principle that I need to follow, or an easy analogy thereof. So what I'm trying to show you is the marks also are distributed according to Fsort. There's a mark for formula, there's a mark for substitution and this substitution, there's a mark for the answer with the correct SI unit, and there's a mark also for the direction. So Fsort assists a lot in terms of how the marks are allocated, how to perform certain calculation. So that is me now trying to get the maximum marks when I am working with momentum and impulse. So it will be 7 because I did everything right. I stated Newton's second law in terms of momentum. I was able to perform calculations using the conservation of linear momentum. But remember, from the achievables, we said it is now somehow around 5 or around 7 depending on the mark allocated. So from the mark allocated, I must always try to achieve the 50%. I am not saying the others are not important, but now the achievables as things that each and every one of us should be able to do. Each and every one of us should be able now to achieve maximum marks. So that is the reason why we say let's have this exam prep to show you how easy, if you follow the right steps, if you do the things the right way, for you to be able to achieve maximum marks. Let's further move on. It says now the magnitude, calculate the magnitude of the impulse. The magnitude of the impulse of car B during the collision. The magnitude of the impulse for car B during the collision. So with this one, 4.22. With this one, the focus now is only car B. So it means I'm going to need this particular velocity as well as the initial velocity, because we say now F net multiplied by changing T is equals to changing P. But now this here represents the impulse, which is equals to m v final minus v initial. My emphasis is you can only use this equation. You see, it's only one mass. Only one mass. So whatever you do, you cannot combine the mass of A and the mass of B and do whatever that needs to be done here. So the focus is only on B, so it means I can only work with the mass of B, and the mass of B was given as 3450. The V final was given now as negative, because remember we said it was moving west, so it is given as negative 16,05, and then we'll have minus 28 again, minus 28. Then I will get my correct answer, which will be 41227. But now what is the problem with my answer? The problem is I have the formula, which will be 1. I have the substitution, which will be 1. I have the answer, but now the answer without the SI unit becomes a challenge, so there will not be a mark for that. Then I'm just going to write here Newton second, then I will be able to get that 1 mark. Does it have a direction? Let's check what did the examiner say. The examiner just wanted the magnitude thereof. So if it's just the magnitude, it's fine. We can omit the direction of the impulse thereof. So that's how easy it gets. But the idea is the achievables. So I was able now to use the impulse momentum theorem to solve problems thereof. So hence we say if each and every one of us is able to address these particular bullets, everything will become clear and easy to perform. Let's move further on. At times now, for the calculations, the scenarios may include collisions and explosion. So the one that we're busy with now was focused more on the collision. So remember, you must also be able to perform for explosions. The principle is still the same. The only idea will be the momentum, or the initial momentum before for the explosion will be 0, and then everything else will follow thereof. We recently learned that graphs also can form part of momentum and impulse. So when you look at different terms and definitions, book 1 that was shared, we have a question there that has momentum versus time. And then in March early this year, we had a problem where we had a velocity versus time. So kindly work with that, because graphs now are coming into the questions more. So it says we are failing to interpret the graphs correctly. We are failing now to understand what is expected out of us. So this is basically application of conservation of momentum and impulse thereof. So once you are able to apply conservation of momentum and as well as impulse, everything will be fine in that regard. Now, work, energy, and power. It's a topic that has a possible of 20 marks. So 20 marks is quite a lot, and it's getting somehow difficult year in, year out, because majority of us learners, we are failing to do it the right way. But history has taught us that also you'll still be able to achieve maximum marks thereof. So the key things to look for here is definitions and laws. So you should be able to give a definition of what is work, be able to state principles, that means work energy theorem, the conservation of mechanical energy, be able to give a definition for conservative, non-conservative, as well as power. But it becomes easy, honestly, once you understand how each principle works. And working with the principles is you need to have key words, and the key words will come from the stem. The stem is the statement given in the question. So from the stem already, we will be able to say which energy principle can work best, which energy principle am I going to look for. So I compiled here a summary of exactly what to look for and when is the other one applicable. So it says to me, I have somehow 3 energy principles. So the 3, and I stand to be corrected, work done by non-conservative force, it's not an energy principle, but I added it here to say it's applicable when we work with energy principles. It assists us in terms of achieving or getting to the correct answer. So when you look at this, I have here work energy theorem. And work energy theorem states that the total work done on an object is equals to the change in kinetic energy of the object. So this one always works, work energy theorem. But now for you to work with work energy theorem, what do you need to do? You need to draw a free body diagram. And then the free body diagram, after identify now all forces that are doing work. So all the forces that are doing work is assisting us in terms of applying now the work equation. So once I am able to draw the correct free body diagram, I'm able to identify all the forces that are doing work. It means I can easily apply work energy theorem. So I'm putting my head on the block and say work energy theorem always works. So if the question comes up and say use energy principles to calculate for 1, 2, 3, then it says the first option that you can go for, it's work energy theorem. But for work energy theorem, remember, you must draw a free body diagram. identify all forces that are doing work, then calculate each work done by each force, and once that is done, everything will become quite easy. Then we have conservation of mechanical energy. For me to apply conservation of mechanical energy, I must have an isolated system. Remember what conservation of mechanical energy is saying. It says the total mechanical energy of an isolated system is conserved. So for me to use conservation of mechanical energy, the system should now be isolated. And once the system is isolated, I am looking for keywords like no friction, no air resistance. So once this is said in the statement, everything becomes easy to say conservation of mechanical energy can be applied. So if friction is there, then it means conservation of mechanical energy won't work. Once the system is not isolated, then it means conservation of mechanical energy will also not work. Now we move to work done by non-conservative force. So I am looking for key things. Key things will be I have friction, I have air resistance, I also have tension. So once in the STEM, in the calculation or the question that is given to me, if friction is there, if air resistance is there, if tension is there, definitely I am going to apply work done by non-conservative force. So they feed on each other. How do they do so? If friction is there, it means I cannot use conservation of mechanical energy, but I can also use work energy theory. But if there is no friction, it means I can directly now go to conservation of mechanical energy and work energy theory. So the two will always be applicable depending on which information is given. So conservation of mechanical energy, if there is no friction, it will work hand in hand with work energy theory. Then if friction is available or it's given or is present, then it means work done by non-conservative force will work, as well as work energy theory. Because we are saying for conservation of mechanical energy, it means the friction should not be there. So this is just a way of saying if I am going to work with energy principle, or I'm going to work with work energy and power, once this is cleared up, once I know when to apply which principle, everything will become easy and very clear. But now we still need to be able to say, where are my achievables? Where can I get maximum marks thereof? Let's look into us achieving the marks. So it will be allocated around plus minus 14 marks. Yes, the slide says 20. The reason for 20 is we can even extend it further to have calculations of power and so forth. So this is just a standard way of saying, but if it's around plus minus 14 marks, somehow I should be able to get my 7. Where do I get my 7? My 7, I get it now from giving the correct definition of work, stating the principles, work energy theorem, conservation of mechanical energy, conservative and non-conservative force. So those are my achievables in this particular chapter or a topic, because it says here I should be able to define work of an object done by a constant force, should be able to draw a force diagram or a free body diagram, distinguish now between positive net work and negative work net, and then apply work energy theorem. That is where I am interested now to say I must apply work energy theorem on horizontal, vertical, inclined planes, both for frictionless and rough surface. It further moves on and say now solve problems involving the equation WNC is equals to E change in EK plus EP. So with that, it says to me somehow I need to be able to use work energy theorem. But remember, I said it's not going to be specific in that regard because it's the summary of energy principles that we need to look into. So once I know which energy principle to address, which energy principle to focus on, everything becomes nice and clear. So kindly be on the lookout that you are able to apply energy principles. So for me to get this minimum or the achievable mark, I need now to be able to distinguish between positive and negative work. Remember, it's just an issue of when do I use a cos of theta that is equals to 0? When do I use a cos of theta that is equals to 180? So that crash course will be done in a couple of minutes. So let's look at the question that was given now in September 2021. A crate of 70 kg starts from rest at point A at the top of the slope and slides down the incline at 25 degrees to the horizontal. The distance from point A to B is 135 meters. The total kinetic friction between the crate and the surface is 150. So already it says to me kinetic friction is there. So if I were to calculate or use any principles here, it says to me the only one that I can look for, maybe I should go back to the slide. Kinetic friction is given, so it means there's no way I can use conservation of mechanical energy because it says no friction. But because friction is there, then I can use work energy theorem. I can use now work done by NC because friction is given already. I am now moving towards the right direction. Even if without looking at the questions, I am able to say, but once friction is there, then the options that I have is for me to use work net is equals to changing EK. Another option is work NC is equals to changing EK plus changing EP. So these are the two options that I have in terms of applying now what? The energy principles already. Because if kinetic energy is there, then it means conservation of mechanical energy will not work. So hence the emphasis of when to use the conservation of mechanical energy as well as other principles related to. But even without looking at the question itself, it says if I am going now to draw, to use work energy theorem, I am expected to draw a free body diagram. Identify the forces that are doing work. So we'll try and solve this one quickly so that at least we speak the same language. Let's move on. It says now define the term non-conservative force. Remember, it should be just easy 2 marks. It's a definition, it's non-negotiables. So all the definitions in a paper, you should be able to achieve maximum marks thereof. So kindly ensure that you know your definitions. I will keep on saying so because every question has a definition and the definitions were given to you, so kindly revise them, know them by heart, don't omit any keywords. So for 5.1, we'll just say A force for which work done in a moving object between 2 points is dependent on the path taken. It's dependent on the path taken. And remember, it's 2 or 0. It's 2 or 0. So it's either you get it right or you get it wrong. So in this case, it's a force for which work done in a moving object between 2 points is dependent on the path taken. So we are looking for the work done and dependent on the path taken. So those are the keywords that the examiner was looking for, and it's either 2 or 0. So you can imagine if you omit keywords, you can imagine now if it happens that you don't write it the right way, then automatically you lose marks, and that is not what we want. Hence, we are here to say, let's give you all the support that you need. Then we further go on and say, calculate the net work done on the grade as it slides from point A to point B. So I am going to use work energy theorem. Remember, we said we have two options. First option is I can use my work net. It's the work energy theorem, work net, which is equals to changing EK. And then I can use work done by NC. Work net is equals to changing EK. But this one was just an option for me to outline what is being asked. But now I am being asked to calculate the work net. So it means the only one that I have for work net in this case can be this one, or calculate for the individual forces thereof. So I am going to try and calculate the work net. But for me to use or to work with work net, it means I need to identify individual forces. So we are at 5.2. So even if the examiner did not ask me to draw a free body diagram, it's always advisable for me to draw a free body diagram. The reason for that is for me to be able to identify forces that are doing work. So once I am able to identify that, I can assign cos of theta equals to 0. I can assign cos of theta equals to 180. So what must I do? Let me draw my free body diagram. This is my surface. I will have my dot there. Then I know that I'll resolve it into components. I will have FG perpendicular. I will have my F normal. I will have my friction in this direction. I will have now my FG parallel in this direction as well. I should have maybe made it somehow longer. 100%. Then it says to me, identify the forces that are doing work. So the forces that are doing work are these two forces. So can I calculate work done by individual force? Yes, I can. What is the direction of the motion? The direction of the motion, it's downwards. So it means everything moving downwards must be now associated with cos of 0. Everything moving upwards must be associated now with 180. But remember, we don't say plus or minus in this case. We only say the force is in the same direction as the displacement. The force is in an opposite direction with the displacement. So if the force is in an opposite direction with the displacement, it means we can use now 180. So we can easily say work done by FG parallel is just FG parallel multiplied by cos of theta. then you can do your calculations and say, but FG parallel is something like mg sine of theta multiply by changing x cos now of theta. I want to emphasize this angle here from the general formula of work, F multiplied by changing x cos of theta. This formula here, this angle here can either be 180 or 0 or even 90 only. But if it's 90, then no work is done. Ne? So I don't want us to be using a lot of conversions and other informations that is given to us. So the only thing when I substitute here should be 0 or 180, depending on the direction of the force. So in this case, I will have my mass of 70, 9.8, then sine of 25. Multiply by 135, and then the cos of either 0 or 180. But FG parallel, it's now in the same direction as the displacement, so it will be 0. Then I will get my answer in joules. I will further move on and say, but I need now to calculate for Fk. So work done by Fk will also be Fk multiplied by changing x cos now of theta. Fk was given as 150, and then the displacement is 135, and then cos of, it can either be 0 or 180. So when I look at the direction of the force, it's in an opposite direction with the displacement, so it will be cos of 180, and then I will get my work done by Fk. So this is me doing it sequentially, doing it step by step for me to be able to clear it out, say when is it a 0 here, when is it 180, because remember, I cannot just automatically compress everything into one, because I want my things to have now a way, a certain sequence, a certain pattern that I am following, so that I make things easy for me. So if I am able to do that, this one will be negative, so I will get something like, the answer here should be 39138,677, and then this one will be negative 20250. So it will be just FG parallel 39138,677 minus now 20250. So the final answer there will be 18,888,67 joules. So I will get it right by so doing. So you can imagine if I wanted now to compress everything into one. So hence I'm saying I am developing a pattern, I am developing a way of us now getting maximum marks. So this is just a way of saying I will get a mark here for the whole substitution, I will get a mark here also for the whole substitution, I will get a mark here also, and then I will also get a mark for the correct formula. So this will be now my nice easy 4 marks. It becomes easy because I did not complicate it. What I did was just for me to draw the free body diagram, but the examiner did not ask anything that has to do with a free body diagram. Can you see that? Hence, it's always important to say, let's follow a certain pattern. Let's draw for the free body diagrams that we're asked to do. Then we further move on to 5.3. 5.3, it will emphasize now also the use of principles. But if you check, if you did now 5.1 correctly and 5.2 correctly, then it means the achievables are done now 100%. So hence I'm saying it is always best to have a reference of what you are looking for, a reference of what is it or where can I be able to get my maximum marks. So now calculate the time it takes when the grade slides from A to B. So for me to get the time, it means somehow the equations of motions should be involved. Because when I look at the equations that I have for work energy theory, let me open my formula sheet. Yes. So when I look at my formula sheet, it says I have F multiplied by changing X cos theta, and then I have a potential energy MGH, and then I have work energy theorem, and the only one that I have, it's this one, P is equals to changing W over changing T. So it says to me somehow it is going to be complex for me to get time if the power is not given. So the only way is now to relate work, energy, and power with the equations of motion. Why equations of motion? Because equations of motion, they now have time there, they have time there, they have time there. So once I can get anything that has to do with velocity, then it's easy for me to include equations of motion. So with that being said, it automatically says I need also to know how to link the two topics, or how to link the information given to the prior knowledge that I have. We spoke of how to use or effectively use equations of motion. So now we are saying, but now from the information that is given, even if the topic is work, energy, and power, there isn't any information or equation that will help me here to arrive at calculating time, because power already is not given. So it says I must calculate something here and then move back to equations of motion such that I can be able to get the time that I am asked to calculate. So I gave you two options to say in this question, because friction is given, one can be us working with work done by work energy theorem, or applying work done by non-conservative force. So for us to do this, it becomes quite easy. We'll use work energy theorem, because at least we have calculated the work net. So at 5.3, we will say 5.3, we will use work net is equals to changing EK. We have calculated work net. I think we got something like 1888,67. So I am not going to substitute that. I want first to break this into a way that I can easily work through. So I have half mv squared final minus half mv squared initial. But I was told that the mass is 70. V final, I don't know what is the V final at the bottom or at B. But what I know is I have half 70 multiplied by 0 squared. That information was given. It started from rest. So already I am able to say, but this one should somehow fall off, because everything multiplied by 0, it's 0. Then I have calculated my work net, which is 18,888,67. Then I can do the math and solve for V final, which is equals to 23.23 meters per second. But now this is just V final. We did not answer or calculate the time thereof. So can I use equations of motion? Yes, I can. What will be the equations of motion? The equations of motion that I can use, it's something that doesn't have acceleration, that doesn't have a lot of complicated things. So I'm going to choose this one. Delta y is equals to V final plus V initial over 2, which is changing t also. Then I will do the mathematics. Delta y was given as 135. V final just calculated is 23.23 plus 0 divided by 2, changing t. Then you'll find that changing t is 1, 1 or 11,625 seconds. 11,265 seconds. So this is the relationship between now the work net or work energy theorem, and then we move now to equations of motions. So it is just an analysis of what the question addresses. It's just an analysis of what information are you able to work with. So if you check there, option 2, I went for option 1 because I felt it will save us time because we already calculated work net. If you are going to work with work done by non-conservative force, it will also become easy because friction was already given. So everything becomes somehow quite easy, but still, you still need the link between work energy principles or energy principles together with equations of motion. So kindly go back, prepare. You know now when to apply energy principles. So the energy principles will forever be part of work energy and power. The question will be which one is more applicable than the other. But remember, the two from this always works. Like the problem that we just did, where we used work energy theorem together with work done by non-conservative force. Let's move further on to Doppler effect. So with Doppler effect, it's plus minus 15 marks in an exam, or it can be something between 11 and 15. So key definitions there are Doppler effect, blue shift, red shift, frequency, Fsort, and also I can include wavelength. That is very, very key. Very, very, very important for us to look into. So the hints of us working with Doppler effect is that one variable will be stationary. So either the source or listener. So then we are expected to apply Doppler effect equation. Very, very, very important. So history has taught me that we do not struggle much with Doppler effect. So I'm not going to extend it that much. But the key idea here is if we are able to define Doppler, we will be able to get our achievables thereof. If we are able to say something about the uses of Doppler in medicine, at least 2, you should be able that they are using it for sonar, ultrasound, those kind of things. So it will be important for us to say at least be able to give 2 uses of Doppler effect in medicine. Because if you are unable to do that, then it says to us everything will be somehow not correct, and then we'll start now losing marks more instead of gaining marks. So let's ensure that whatever we do, we look into a way of saying, am I able to give at least 2 uses of Doppler effect when asked to do so. So one will be measure the rate of blood flow, measure the heartbeat of the fetus, and then can also be used in speed traps for controlling traffic and thereof. So at least know 2 that you are sure of, especially in the medical field. So if you are able to give those, then I believe everything will be fine with us. So key point: one variable should be stationary and will be stationary. That information will be given to us. So thereof, you'll be able to apply a Doppler effect equation, and then at the same time now uses Doppler or uses of Doppler in medicine, and explain why the universe is expanding. This is where red shift and blue shift comes handy. So I will just show the achievables when we work with Doppler. So with Doppler effect, it means, it says here, explain Doppler effect. That will be your 2 marks. Explain red shift or blue shift, also easy 2 marks. Explain using appropriate illustrations the change in pitch that can be observed when the source moves towards or away from the listener. This hasn't been assessed quite a lot, but I have a feeling that we are expected now to be able to draw those diagrams to show the compression of the wavelength and the expansion thereof, that when it's moving towards me, there's going to be higher compression. That means shorter wavelength, higher pitch or higher frequency. So we need now to start looking into, are we able to draw those illustrations there that shows the change in pitch when the source is moving away and towards the listener. Solve problems using Doppler equation. Very, very important. There is no way that the question can be there and then you don't apply a Doppler effect. The other part here will be state applications of Doppler effect. So those are the ones that we spoke about, to say somehow you need to be able to state applications of Doppler effect. Use the Doppler effect to explain why we conclude that the universe is expanding. That is now the red shift. So those are the achievables, and we need now to look into that. We further move on to electrostatics. So with electrostatics, it is important for you to be able to define Coulomb's law, be able to define what is an electric field, and now be able to perform calculations that includes 2 to a maximum of 3 charges that are arranged now in 1D and 2D. So if we are working with Coulomb's law, the equation is this equation here. So we must be able to solve problems using the equation of Coulomb's law for both 1D and 2D, limited now to 3 charges. So 2D and 1D. So the question should be, when do I know that I'm dealing with 1D or 2D? So 1D will be a situation where you have Q1, Q2, as well as Q3. This one might be negative, positive, positive, depending on what the examiner is trying to assess. At the same time, you'll have this information here. Let's say this one is 2 meters, and then you have this information here also, which is 2 meters. So the total thereof is something like 4 meters. So honestly, it depends on what the examiner is trying to assess. But in this situation of 1D, it says a reference charge will always be given. A reference charge will always be given. So what do I say about the reference charge? A reference charge will be the focus charge that all the calculations are based on. Even if we are calculating for for FNet, that is experienced by a charge, it will be easy to say calculate the resultant force or net force experienced by Q1 due to Q2 and Q3. So the reference charge in that case will be Q1. So a reference charge will always be given. And even if we draw our free body diagrams in this section, a reference charge will be given. That is when now I am working with 1D problem. But what happens in a situation where I am working with a 2D? 2D, I will have my Q1, have now my Q2, and have now my Q3. Also negative, positive, positive. But now the arrangement forms a way that I have now this perpendicular angle between the two. So in this case, it's easy for us to say the reference charge will always be the one at the center. It will always be the one at the center. That is very, very key. So the one that is at the center will now be our reference charge when we look at the two. So that is very, very important to understand. Very, very, very important. So this is us applying Coulomb's law for a situation of 1D, a situation of 2D as well. Then we further goes on and say, but now draw the electric field pattern. So when we draw the electric field pattern, and also calculate the electric field at a point due to a number of point charges. So that is what is expected of me, to be able also to draw the electric field patterns. So now let's look at the question that was given in September, the question paper we are busy with. The very first one, the idea is, because the total is 16 marks, somehow I should be able to achieve at least 8 marks, which is the achievable per the outline here. So somehow I must be able to get the 8 marks. But where is the 8 marks? The 8 marks is sitting at me being able to define what is electric field. For me to be able to draw the electric field pattern, this should be easy marks for me, because even if when I look at the memo, it's quite easy. The definition, the electric field at the point is the electrostatic force experienced per unit positive charge. Thereafter, it is just the drawing, correct direction towards the sphere, and then field lines are not crossing and are radial. So I should be able to get that 2 marks. So where do I need now another at least 4 marks? I need the other 4 marks now in either using the electric field or solving the problems using using Coulomb's law. So that is what I expect to be assessed on as per the plan of the examiner. So that will be the easy way of getting now marks on this particular question. So we will not go into detail with it, but the idea is we know now the achievables, we know what to look for. We are also able to say this is things that I need now to look into. So it will be around plus minus 17 marks. So kindly ensure that you are able to achieve about 50%. Let's look at electricity. With electricity, it is important to know Ohm's law, internal resistance, ionic and non-ionic conductors, power, and EMF as well. But when you are given a circuit to work with, it is always important to redraw the circuit, or the best way is for you to write on top of the question. Because if you follow the current path, then it will include what is asked. Identify one variable that is given and then one that is hidden. So that is now us applying the science. So one will be given and then one will be hidden. So basically you just need two variables for us to work with the electricity. I'm going to try and show you this part here of equations under electricity to say we only need just two. You see, we only need R or I, we only need R or EMF, we only need just one, just two. So if we have two, even if when you are working with power, if you are able to identify the two variables that are given to you, everything will somehow become quite clear. So the idea thereof is redraw, apply Newton's law, and be able to perform calculations for the cost of electricity. Motors and generators, it is important there to look into generator and a motor. What is a generator? What is a motor? Focusing on energy conversion between the two. Define a root mean square. Be able also to define Faraday's law of electromagnetic induction and identify components of AC and DC. So applying the components or identifying the components, it is going to assist you in terms of classifying whether this machine is a motor or is a generator. If it's a motor, is it an AC motor or a DC motor? So the easiest way of doing that is identifying the components thereof. So once you identify the components, it becomes easy, because when it becomes easy, it's the calculations and the reasoning thereof, they follow each other suit. So kindly go back, look into identifying the components. I believe this section is the section that you should be busy with at your school, as one of the topics that was behind from the curriculum coverages that we received from independent schools. So kindly go back, look into, are you able to identify AC and DC motor in terms of the components? Are you able to differentiate when is it a motor and when is it a generator? So the easiest way for me to identify a motor is to say it should have a power source. So once there is a power source, generally it should say it is a motor. Once there is no power source, then it must be a generator. but now it follows thereafter to say what type or which type of a motor it is. Is it an AC? Is it a DC? So if it has split rings, what does that necessarily mean? If it has slip rings, what does that necessarily mean? So thereafter, it means in this particular topic, I am going to be able to achieve maximum marks. Thereafter, it says, but I must also be able to apply Fleming's right and left hand rule. So the achievables thereof also, it's us being able to state energy conversion in generators as well as motors, use energy principle, electromagnetic induction to explain how energy principles work, explain the functions of components of AC and DC generator, state examples and uses of AC generators, state now energy conversion in motors, use motor effect to explain how motors work, explain the functions of components of a motor, and state now examples and uses of a motor. So once that is done, it means I'm able to close the gaps. I am able now to say, but regardless of whatever diagram that is given to me, regardless of whatever diagram is given to me, I will be able to easily say, is this a generator or a motor? Then I can be able to answer it correctly by saying, looking at the components given, looking at the diagram thereof, I can easily say the diagram above should be now be a generator. It's as simple as that. Why? Because we don't have any power source, we don't have any form of a source that gives this cell or this machine a way to operate. Thereafter, the second question says, name the principle on which the machine operates. Because it is a generator, it must be electromagnetic induction. That is the reason why I said here we look now into key things of how best can we identify whether the machine is a DC, it's a generator or a motor. So that is the best way we can go with. So for me, I believe that will be clear in terms of how to approach this particular question. And if you look at 9.41, it says, how long does it take for a coil ABCD to complete one rotation? It's a calculation thereof. In which direction is the coil rotating? Choose the clockwise or anti-clockwise. So in this case, that is where now, because it is a generator, it means I must use my right hand, and then I will be able to apply it correctly. So it is very, very important also, such that we prepare for this particular exam. Then the last topic under paper 1 is photoelectric effect. So it is also important now to define photoelectric effect, work function, threshold frequency, and as well as being able to calculate. So two variables will be given, one will be hidden, and also explain the intensity and frequency of incident light. But lately they are asking it in terms of graphs. They are asking intensity, if it's increased, how is it going to influence the current thereof? I should be able to do so. So if you check, this is now the 8 marks that each and every one of us should be able to get. So with that being said, it says, when we go back and prepare, let's look for the achievables per per topic. There should be something that you are able to do. There should be something that when you look at the question paper, you are able to answer it correctly. So when we meet in the second part of this exam preparation, we'll look into paper 2. I believe we tried now to outline the misconceptions and the common errors that you are doing as learners, and we tried to give you strategies or mechanisms or a way of making things somehow easy for you. So the achievables are in each and every topic. So the idea is, how best can I get maximum marks from each? So we will meet again very soon, and the focus will be now on paper 2. So thank you very much, and all the best for your coming examinations. Thank you.